Hey everybody, my name is Christine Javier, and today I'm going to work on Factorialize a number on Free Code Camp. So essentially here, we're going to have a function called Factorialize. A number is going to be passed in, and we're going to take the factorial of it and find its product. So a factorial is a number where you just consecutively reduce and get that product of each integer that you're reducing. So it would be with the number 5 factorial, it would be 5 times 4 times 3 times 2 times 1, and it would be that product. So let's go ahead and work on this. This was a cool problem because I got to practice two fundamental programming skills, one of which is using a while loop and the other using recursion. So I'm going to show you both today. All right, so I'm going to start with the while loop. Using while loop. Okay, and I'm just going to set up my console.log. I'm going to take off the semicolon because I always forget that for some reason. There we go. And then we're going to keep running it as we go along. So let's see. Now let's set up the while loop. The idea is you want to keep doing a certain action until you no longer want to. And the question is, at what point do you no longer want to keep multiplying? And for this instance, we're going to set our while loop so that it'll stop once num is greater than 1. And the reason I'm not setting this to 0 is because when you consider a factorial, the last two numbers are always going to be times 2 times 1. And you don't have to go about doing this step. You really just have to stick with just that point, and it's going to equal the same thing. So, I mean, it's like a little thing, but it technically is a little more, it's a little better that way. It's a little more efficient as far as runtime goes, but it's slight. And it's cool. It's a kind of demonstration of your knowledge of factorials. Okay, so while num is greater than 1, we're going to do something. The question is now what? Just to further set up my while loop, forgive me if this seems super disordered, but it's just the way I think. I already know I want to reduce num as we go along so that it could the while loop could function properly, because you're going to need to reduce num in order to have the while loop stop at some point, right? Okay, so now the question is, what are we going to do? I'm going to set another variable. Let's just call this answer. And answer is going to equal 1. And we're not going to return num, we're going to return answer. So my thinking here is that we're going to have this number 1, and we're going to keep multiplying this one figure by num as it keeps reducing. So thinking more, well, let's go inside the while loop. Answer within each loop is simply going to evolve into answer times whatever num is, right? So let's go ahead and run this. This should equal 120. Good. All right. So let me explain this in an ordered way so that you'll be a little less confused about the way I think. So we have the number here that's the argument. We've declared a variable called answer, which is set equal to 1. While the argument is greater than 1, we're going to keep multiplying the number argument times answer. And not only is it being multiplied, it's being multiplied and added to. So this operator here is very essential. It's like essentially saying answer now equals answer times num. And that's significant, right? Because you want to maintain the previous value of what answer was in the previous loop. You know, you can't just go with answer times num because, or you have to keep appending and adding onto what the previous value of answer was. So that's why this operator is important. And that's just the shorthand of what I showed you just earlier. Okay, so this is using the while loop. And just to reiterate something, the reason why I went about it in a weird way is because I like to just broadly set up my loops like that, like my while loops, just so I kind of get an idea of like, okay, it's gonna stop at this point for sure. Like it has to stop once num equals 2, right? So that's why I kind of went about it that way as opposed to going line by line by line. And that's just a logic that has helped me. But if it's easier for you to just go about it line by line like this, that's totally cool too. All right, so that's using the while loop, which is great. Now let's go ahead and practice using recursion. And I'm just going to comment this out. All right, let's add in a few lines here. Cool. And this is called Factorialize, right? Okay. So declare the function Factorialize. It's going to take in num as the argument. There we go. Cool. So what is recursion and why does it scare people so? It's kind of a trippy idea, but in its most simplest form, simplest idea that it could be communicated to anyone, it's the idea that you're calling a function until you're no longer calling it. So similar to a while loop, you set a condition for when you want to get out of your recursive function. And it's scary to people because it sounds very mathy, and usually it's taught with Fibonacci numbers, and it doesn't have to be. It's just keep calling a function until you no longer want to because of a certain condition. All right, so now let's go ahead and practice that. And this function is going to be actually it's going to look pretty similar to the while loop actually. All right, so let's declare answer. Let's set it equal to 1. Now, what do we want to do here? We want to say, we want to create the action where answer now equals answer times num, and then we want to reduce num. Now we're saying if num is greater than 1, then we're going to just call Factorialize again, with num being its new figure. So let's just go through this real quick. The argument is 5. Num equals 5. We've declared a variable called answer, which equals 1. Answer now equals answer times num. So in other words, num now equals 5. Now, let's go ahead and reduce num by 1. Now, num equals 4. Okay, so then we're going to enter this if statement. It's asking, hey, is num greater than 1? Well, num is equal to 4, so yes, that's true. This evaluates to true. And because it evaluates to true, we're going to call Factorialize num. But what does num equal now? Num equals 4. So we're going to go back into the Factorialize function again. And num's going to equal 4. Answer again equals 1. And this is already the main mistake. We want to put var answer in a global scale because at that step, we're going to reevaluate answer equaling 1 again. And it's going to be 1 times equals 4, which is going to equal 4. And that's not what we want. We want to do 5 times 4. So please forgive me for that confusion. Let me go over again and quickly talk as if I'm the JavaScript engine and I'm parsing this through. We have a global variable declared as 1. So this is outside of our function, which is key to why this recursion works. All right. Answer equals 1, but at the point where num is 5, answer now equals 5. Num is reduced, num equals 4. Num is greater than 4, yeah. So we're going to call Factorialize again with num equaling 4. Now, keep in mind, because this is global, answer has maintained its previous value of 5 without having to be redeclared as 1. So that was key. So when it was like this, it kept redeclaring as 1, and we didn't want that. We wanted answer to keep changing. So that's why you want to set this in a global scale. All right. So yeah. So then at the point where num is 4, answer times equals 4. So 5 times 4 equals 20. 4 is reduced, so now it equals 3. And then you're asking, is num greater than 1? Yeah. So because num's 3. We're going to call Factorialize again with 3. And then it's going to be 20 times 3. And that's going to equal 60. So yeah, that's the mentality You just keep going on and on like that. All right. Now, it's going to come to a point where num is no longer greater than 1. So what's going to happen then? We should just return answer. That's all. Now, what figure should we expect? 120. When we run this. There we go, 120. Good, so that works. Now, let me go ahead, because, okay, freed code camp's kind of weird. I want to just show you something really quick. So this is our first answer using the while loop. I'm just going to input that and prove to you that this works. Forgive me for not doing that earlier. I was just so excited to get to recursion. Okay, so the first while loop works, as we expected. Great. Now let's reset this. And I'm going to show you something kind of interesting with freed code camp. Let's do the one, input the one with recursion, which we've proven does work. Cool. And as you can see, it doesn't run. So free code camp's awesome, but the issue is I think it has like a bug where something like it considers the global variable in its answering. So even though in reality this totally works, just in order to have this pass in free code camp, we have to do something slightly different, okay? Now, I mentioned the importance of keeping answer on a global scale, right? So that it doesn't keep redeclaring and resetting its value as 1 every time we go into our, we call our function, right? So we have to keep that in mind when we're refactoring this code so that it satisfies the test for free code camp. So anyway, the point I'm driving at here is free code camp doesn't recognize this for some reason. So what you have to do is declare an inner function. That's essentially this, but it's just like, it's kind of more meta. It's a little like, you know, function inception, where you have to just like declare another inner function and then call that inner function. So I'm just going to show you exactly what I mean. You're probably like, what is she freaking talking about? But it's going to make sense in a second. So, let's see. So, okay, we're gonna declare this, and we're gonna declare an inner function called inner func. Let me just take out all this mess so that it's a little less confusing. Okay, so now we have an inner function. Now, what's important about this is that var answer equals 1 is declared. Yes, it is declared within the scope of Factorialize. However, it's considered a global variable in the context of inner function. So we're gonna write pretty much the exact same code within this inner function as we did previously. The importance of creating this is to create an inner scope so that it could access this global variable and not have it become redeclared upon every call. Okay, so let me just go through it again. Now, again, the idea is you want to keep calling a function until you no longer want to. And in this case, you no longer want to once the number is equal to 1. So let's see, we're going to do answer times equals num. Okay. Then we're going to do num minus minus. Okay. And we're going to say if num is greater than 1, then we want to keep calling that function. We're going to call inner func. Oh, and also it's going to take in a parameter. We're going to say input. And then, let's see. So then inner func, yeah, inner func times num. All right. Then, let's see. And then, let's see. Yeah, and then outside of this function, you just want to return answer. And I forgot an important step here. So because we have this inner function, you have to call the inner function right after you declare this variable here. So we're going to have to call inner func num. All right. Now, let me just run this and make sure it works, and I'll go and explain exactly what's happening. There we go. So it equals 120 as we expected. Now, okay, let me explain what my thinking was, because I realized that probably felt really disorganized, but such is my coding brain. However, I am comfortable with explaining what I did, so hopefully that will help you out. Okay, so we have this outer function called Factorialize, and inside of it, we've created a variable called answer, and we set it equal to 1. Now, the next step is we're going to call the inner function. So you must understand that, and this kind of has to do with, this kind of matches with the way things are indented as well. This inner function is a more localized scope than this outer function here. So anything inside this function has access to the outside of it. Okay, and that's kind of just the concept of dealing with scope and dealing with execution context. So the scope is outer compared to there. Okay, so we're calling this inner function with the argument num. At this point, num equals 5, right? Okay, so let's keep in mind, num equals 5. We're going to input 5 within this. 5 is the argument for this input parameter. Answer at this point equals 1. We're going to set 1 equal to 1 times num. So it equals 5 at this point. We're reducing the num by 1, which at this point is 4. And we're asking, hey, is num greater than 1? Yes, it is. So we're going to call inner func again with the argument 4. Let's go back up to line 16. Input now is equal to 4. Answer at this point is equal to 5. So we're saying 5 times 5, answer equals 5 times 4. So now at this point it equals 20. We're going to reduce num by 1, so it's going to equal 3. At line 19, it's asking, hey, is num, which is equal to 3, greater than 1? Yes, it is. So we're going to call inner func again with a value 3. Go back up to line 16. Answer is equal to 20. We're setting answer equal to 20 times 3, which now equals 60. And we're saying, okay, reduce num by 1. Okay, it equals 2. And is 2 greater than 1? Yes, it is. We're going to call inner func with the number 2. Let's go back up to line 16. Answer equals 60. So we're setting answer equal to 60 times num. Num equals 2, so the answer is 120. We're going to subtract num by 1, and it's going to equal 1. We're at line 19. Is num greater than 1? Actually, no, it's not. It's false. And right outside here, we could have written an else statement, but you don't have to, because without that else, with just the way things are written, it's going to exit out of the function. It's going to go to the very next line where there's an order, and it says number 20 on line 23, return answer. Answer equals 120. So that is the thinking behind recursion. And a great tool to just look and see how this is happening. And I've referred to this in my past videos. Go to something called Python Tutor. They have a JavaScript section, so it's technically called JavaScript Tutor, but it's on pythontutor.com. You could literally paste in the code that we just went through. Factorialize 5. And go step by step into how the JavaScript engine is working and analyze exactly what's happening, how these variables are changing with each step. It's such a great resource, and that's a huge part of a huge tool I have to make things mesh in my mind, to connect the dots for myself. And I love that it's visual too. Okay, so now let's see if our recursion works. Factorialize 0 should... Okay, Factorialize 0 should return 1. Let's see. Why doesn't that work? Factorialize 0 should return... Yeah, that should work. I wonder why that's not working. Function Factorialize 0. Okay, let's see what's happening here. Oh, it's returning 0. Answer equals 1. Inner func times no. We're going to exit out of there. I see. Okay, so let's write another if statement. If input equals 0, answer equals 1. If input equals 0, if input equals 0, answer equals 1. Okay, return answer. There we go. Okay, please excuse me for that. The issue for that test not working is because of this line 21 here. Answer is answer equals answer times num. So if num were to equal 0, answer would become 0, and we don't want that. So I just set a quick if statement here to account for that possibility for that test. So we're saying, okay, the very first thing is input equal to 0. If so, answer is set equal to 1. Return answer. And actually, we don't even need line 18. Yeah, there you go. So let's try that function now. There we go. And it works. Hopefully that's helped you out. I love practicing recursion because it totally is something that is healthy for your coding brain, and as well as while loops. And really, they're actually quite similar, you know, with the concept that you're just kind of doing something until you no longer want to do it. And that has to do with all looping, really. But recursion is just a scary word, and I'm trying to grow comfortable with it. All right, have a good day. Thank you.